Good morning. Thank you for introducing me. I am working at the Joint Research Center, and also thanks to the EIP-AGRI team for the invitation to present results of the work we are doing in collaboration with INRA to support EIP-AGRI in the evaluation of the CAP, Common Agricultural Policy Strategic Plans. We are analyzing the impact of about 50 farming practices that are aimed at reducing impacts on the environment and climate. Today, in this seminar on healthy soils for Europe, I'm going to briefly present the impact of 5 farming practices that can reduce the use of fertilizers. Next slide, please. These practices are very important because excess fertilization leads to excess of nutrients in the soil, water, and air, which in turn has negative impacts on biodiversity, climate, and many ecosystem services. This was also stressed yesterday in the session of fertilizer efficiency. That was very interesting. The Farm to Fork strategy has set up clear targets about fertilizers use. In 9 years' time, the EU agriculture needs to reduce the use of fertilizers by at least 20% and reduce the nutrient losses by at least 50%. These targets, as we realize, are very challenging, and particularly for those member states or regions in Europe with nitrogen excess in the soils, but also with nitrogen vulnerable areas. Next slide, please. Our analysis is based on the evidence from hundreds of field experiments assessing the impacts of fertilization practices that have been reported in studies that I symbolize here with this yellow green dot. These images show examples of field experiments with different fertilization strategies. For example, you can see here on the right side of the slide an experiment in which they are comparing fertilization with different amounts of urine or mineral fertilizer with no fertilization here in the middle as control. And below you can see another experiment where they are measuring the impact of inorganic and organic fertilizers on the emissions of nitrous oxide that, as you know, is a very powerful greenhouse gas. However, an individual study about the effectiveness of fertilization practices does not tell us as much as we would like. We need multiple studies to reassure us that the results are robust. Next slide, please. Ideally, we would also like to see how a farming practice performs in different contexts. Our evidence comes from experiments in many countries in the world. In this example, you can see the global distribution of studies reporting a total of 521 observations about the effects of manure types. You can see here the manure types on the left side: sheep, poultry, pig, green, farmyard, cattle, on soil biochemical properties. The graph here in the middle with these green dots shows the climatic conditions for all the study locations. So we get also an idea of what is the importance of temperature or precipitation in the results obtained. Next slide, please. The evidence from many fertilization studies has been gathered and analyzed statistically in scientific papers called meta-analysis. The example that I showed in the slide before is a meta-analysis based on many studies on manure fertilization. Meta-analysis can make large amounts of data obtained from many studies, these green dots, more accessible to decision makers who might otherwise be at loss when faced with contradictory or seemingly insignificant information from studies. So because we need to gather a lot of information in this work at ERC in a short time, we have developed a method that uses the many meta-analyses, so these orange dots, in different web libraries. What do? We search the web, we select the relevant meta-analyses, we read them, and we extract the data on the impacts, in this case, of fertilization practices, but also on the factors that influence the EIP-AGRI and the knowledge gaps. Next slide, please. We have reviewed so far 5 fertilization strategies that can reduce the fertilizer use by increasing the fertilizer efficiency. These practices are organic fertilization, green manure, enhanced efficiency fertilizers, and part of them, because it's really important, nitrification inhibitors, and low ammonia emission techniques. You can see here on the right some examples of these practices. Next slide, please. In our searching the web of meta-analysis, we found that there are hundreds of studies already published for these 5 fertilization practices. In the figure, you can see the number of meta-analyses. These are these bars in orange color that we found for each of the practices, but also the range of the number of studies included in each meta-analysis. For example, you can see here the first bar on the left. Organic fertilization has the highest number of evidence in the web, with 33 meta-analyses, including from 10 to 238 studies. This illustrates how robust is the evidence behind our analysis, and also the little risk of bias, because we use a comprehensive set of available studies and not a subset that could lead to biased information. Next slide, please. The next 2 slides illustrate the results of our review for 2 of the fertilization practices. This one shows the effect of organic fertilization compared to mineral fertilization. There are many positive impacts that I've marked in green. You see there are decreases in ammonia emissions, so to the air, to water, so nitrogen leaching, benefits for the soil health, the biological quality, the soil nutrients, mainly nitrogen, and the soil organic carbon. Importantly, because this is also very important for farmers, the use of organic fertilizer does not have effect on the crop yields compared to mineral fertilization. An attention point is that sometimes increases the emissions of carbon dioxide. The next slide, please, shows one of the other practices. This is nitrification inhibitors. As you know, nitrification inhibitors, what they do is that they cause that mineral nitrogen is retained as ammonium, which is less prone to leaching than nitrate, and which cannot be lost to the atmosphere by nitrification. And indeed, you see this back in the effects. We find a decrease in nitric oxide, that is an air pollutant, and nitrous oxide, that is a greenhouse gas. Nitrogen leaching, increase in plant nitrogen uptake, which results in increased yields compared to fertilization without nitrification inhibitors. Attention to the increases in ammonia emissions. The comparison of the 2 slides shows that the impacts differ per fertilization practice, and this is important to consider when you are designing your fertilization intervention. Finally, the last slide is the takeaway messages. So in conclusion, the results of our systematic review of meta-analysis shows that the 5 fertilization practices have overall positive effects on nitrogen use efficiency, soil quality, and yield compared to the controls use. But there are as well some negative impacts that need to be considered. These results can be used by farmers and other decision makers to identify best fertilization practices targeted to the specific climatic and soil conditions, and also as benchmark to compare their own results. Our method provides robust evidence based on hundreds of experiments and reduces the risk of bias because using a limited sample of experiments can lead to poor or contradictory decisions. It also identifies which biogeographical and climatic factors, like temperature and precipitation, but also management, so organic fertilization application rate, duration of the treatment, how they modify the effects. This is my last slide, and I thank you very much for your attention.